Okay, so we're given this probability density function, and we're told that it's defined on this interval, and we are also given that we need to find the probability that x takes a value between 3 and 4, right? So first of all, what do we need to know about, what information do we need to know to solve this problem, right? First thing is that for 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 a domain J, the area under the curve, right? The area under the curve, so it's the integral over J of the probability density function gives us a value of 1. That means if x is defined in this domain, it is certain that it takes a value between these two value interval between in this interval, correct? So what this is saying is essentially that if x is guaranteed to have some value in this domain, that's basically what it says, right? So we that's one thing we need to remember. And then given that, we need to find this probability that x takes a value between 3 and 4. But first we need to solve for this c value, right? So in this case, what we need to do is we need to do the integral of cx times 4 minus x dx over some domain. So in this case j is j is 0 to 4. Okay, this holds in this domain, right? So we are going to say that between 0 and 4 this holds. Now we can go ahead and try and solve this, right? So, and this equals 1. Okay, so we can just pop the c out. It's a constant, 0 to 4, x times 4 minus x dx equals 1. Let's just expand this out, so that gives us c 0 to 4, 4x minus x squared dx equals 1. Right? So now we know that we can separate these two out. Okay, so we know that this is the same as saying c times the integral between 0 and 4 of 4x dx minus the integral of between 0 and 4 of x squared dx, correct? Okay, so now that gives us, so let's just go ahead and integrate. These are quite straightforward, right? This is just power, using the power rule, sort of the power rule of integration, which says that we can just increase the exponent and divide by that number. So this gives us 4x squared over 2 between 0 and 4 minus x cubed over 3 between 0 and 4. Okay, so given that that's the case, all right, so now we can just evaluate these numbers out, right? So let's just recall the fundamental theorem of calculus, which says that of between a and b for any function f of x dx, this is equal to the antiderivative, so capital X of b minus the antiderivative of a. Okay, so that's what we're using here, right? So now we're just gonna go ahead and say, all right, so this is gonna be equal to c times, so this is just 2, right? So c times 2 times 4 squared minus 2 times 0 squared minus 4 over 4 cubed over 3 minus 0 cubed over 3. Okay, and that gives us c times 32 minus 64 over 3 and that's C 32 over 3. Okay, and we know this whole thing equals to 1, right? So we know that. So in that, so I'm just gonna bring this up here. So we know that 32 C times 32 over 3 has to equal 1, right? Therefore C is 3 over 32. Okay, just moving these things around. Okay, so we have this now, right? We can just bring this value into this equation. So that gives us that P of, so now we have that P of x is actually 3 over 32 times x times 4 minus x. Okay, and now we can get to figuring out exactly what we want, which is this part, right? So what we asked is that probability that x takes a value between 4 and 3, okay, and that's equal to the same thing, except now we have different boundaries, right? So this is the exact same process. We just do the integral of P of x, which is now this value, this function, right? So 3 over 32 times x times 4 minus x, and we use this boundary now. So we are interested in this interval. So it's just, so in this case j equals, so in this case j equals 3 and 4, right? So between 3 and 4, that's and dx. Okay, and that'll give us the answer. So let's just work this out. I'm going to pull this 3 over 30 to the outside, which is the same thing we did here with c, right? And then that's going to be the integral between 3 and 4 of 4x minus x squared dx. Okay, so we already did this integration over here, right? So we're going to end up with the exact same function. So that's just going to be 3 over 32 times 2x squared evaluated now except at these two boundaries, so 3 and 4 minus x cubed over 3 evaluated at between 3 and 4. Okay, so it's just this result, except now we have different boundaries, and instead of c we have the value of actually of what c is. And then once we just, and if you do, and then you apply this, right, the fundamental theorem of calculus, and you get the final result is going to be 33 over 32. So this exact same process over here. I'm just going to write that. I'm just not going to write that out. It's going to give you 14 minus 37 over 3, which is going to equal 5 over 32, which is approximately 0.16. Okay, so this is the probability that x is between less than or equal to 4 or greater than or equals to 3. Okay, that's the answer. A good way to check if you got, one good indication if you did this correctly is if this is a value greater than 1 or less than 0, you probably did something wrong, right? Because probabilities always have to be between 0 and 1. Okay.